All right. Well, good morning and Merry Christmas to you. So we have a 2-day test this week. Wednesday is the multiple choice. Thursday is free response. It's all no calculator. We haven't done a whole lot of working with the calculator, so we'll stick with no calculator. I'll talk a little bit later today about what you have to do with the calculator on the AP test, what they expect you to be able to do with the calculator. So kind of looking ahead, today and tomorrow is review. There's only one worksheet that I'm going to give you today, and it'll be sort of today and tomorrow's review. It's the semester review, page 1 and 2. So if you haven't started it, or if you don't plan on starting it, or whatever, but today's worksheet is the semester review. I guess we could say today's page 1, and tomorrow is the semester review, page 2. But it's kind of spaced out, so that means today is 5 problems and tomorrow is 4 problems. So I'll just give them to you both today, and you can kind of figure out when you want to work those. If you want to work the rest of the 10 pages of that to get ready for the final, they're posted online, and I'll leave it for you to either print them out, or you could just work them on your own paper as you look at the, if you don't want to spool out 12 pages or 10 pages of printer paper. You could just work them on your own. So that's the assignment. That's your job for today and tomorrow, is just 1 page front and back, more review questions. Not a big deal. What I want to do most of today, and maybe less so tomorrow, is talk about what's on our test and what's on the AP test. I mean, there should be overlap. Like, what's on our test is an old AP test, so it's a similar conversation. But before we do that, let's do some warm-ups, some test-inspired warm-ups at that. The best kind, right? I mean, if you got to have warm-ups, they may as well be test-inspired. There's 4 of them, just to make them fit on the page nice and neat. We'll do 2 and 2. The first one, there's 2 questions. So this happens a lot on the free response part of the AP test. They ask multiple questions, and so neither one of those is really that hard, but it's to get you to make sure you read all of the question, answer both questions, make sure both questions are labeled. If you just box up 3 and then box up 7, I don't know who goes with who. So part of 1 is the subject matter covered in number 1, but part of number 1 is making sure that you answer both questions and label them so that I know which questions you've answered. Number 2 is an algebra, I guess it's a trig kind of thing. I would say it's not a calculator. In fact, all of these are no calculator. So you'll have to think about number 2. There's not a whole lot of computation on number 2, but there is a little bit of thinking about number 2. You know what? Let me clarify that. Let's solve that on the interval 0 to 2 pi. Otherwise, there's an infinite number of answers. All right, so try 1 and 2, then we'll come back and go over them. And then again, there's a 3 and 4, but we'll get those in a little bit. Slope of a tangent line, so that would require f prime at 2. So we'll find f prime and then plug in 2. Derivative of natural log is argument in the bottom, and then times the derivative of the argument, or just put the derivative of the argument in the top. So 2x plus 3 in the top. So f prime of 2 would be plug in 2. That would be a safe stop. You could stop there and be good. Most of you carried it on to completion, which is fine, and get 7/20ths. But don't just box up 7/20ths, because then I'm not clear is your answer 7/20ths to the first question or to the second question? So make sure it's clear, and it might be that 7/20ths is equal to f prime at 2. At what value of x does f have a horizontal tangent line? Now, some of you said this out loud as soon as you saw it. Your brain should certainly think it. Horizontal tangent line. So slope equals 0. That means f prime equals 0. So we'll set 0 equal to the derivative. But the bottom doesn't really even matter, right? Because for a fraction to be 0, the only way that happens is if the top is 0. So there's a horizontal tangent line at x equals -3/2. So if you just put x equals -3/2, that's dangerous when more than one question is asked. So be careful. If these were like really separated, and on the AP test they might be like that might be part A and part B, and your answer document has like half a page for part A, half a page for part B. So you'd be okay. You'd just show your work, and you'd get there, and you'd be fine. But if they were jammed into the same part, and all I see is 7/20ths and -3/2, it's like, well, which one's which? Unless your work is clearly shown. So be careful when more than one question is asked.
Is it always setting the derivative equal to that?
Yes. Because horizontal means this, slope 0. Tangent line means derivative, so the derivative equal to 0. So it's just another way of asking that question. Number 2. I think I would move the cosine over and then just start thinking where does sine equal cosine. And hopefully you think pi over 4 is not too bad, because that's where they're both root 2 over 2. And then outside of that quadrant, they have different signs, except in the third quadrant, they're both negative. So that would be 5 pi over 4. You're not going to get a question that's where that's the question, but you could get a question where that's, the third step down after you take a derivative, and maybe I should have said find the horizontal tangent line to whatever would give you this as a derivative. So this was just an algebra pre-cal reminder that you might have to use on Wednesday or Thursday. Questions on either of those? All right, 3 and 4. Again, you try those. We'll come back and go over them in a minute. Again, looking at 3, you're supposed to recognize that that's the form of a derivative. That's the definition of a derivative, where f of x is sine and x is 4. So f of x is sine, x is pi over 4. So the derivative is cosine, and then plug in pi over 4, and you get root 2 over 2. Number 4, f and g are inverses. So let's see. Yes, I usually like to do a table with this. F and g, point x, y, and then I don't want to call it f prime because one of them is g prime. I'll call it dy dx. I need a derivative entry into my table. So if f of 1 is 2, what does that mean the point is on f? If f of 1 is 2,
So
what's the ordered pair?
2, 1.
1, 2.
Which one? Is it 1, 2 or 2, 1?
What? Wait, who's right?
2, 1.
So f
It's
of 1.
one,
If it was
two.
1 is x, and then
1 is x and 2 is y.
Oh, wait,
Haha.
And what's dy dx of f at 1, 2?
Wait.
What's
So
the
it's
derivative of
-12.
f at 1? -12. They just gave us that. Most of the time, they're not going to give you that. They'll have you find that. I just wanted to make this one go
Wait,
quicker.
So is the derivative of g like 1 over 12?
So what's the point that would be on g?
2, 1.
2, 1. Trade places. And what's dy dx of g? What's the derivative of g at 2?
Wait, -1.
This is what we're trying to find, right?
Yeah.
Oh, and then you just flip it.
You just flip it.
Oh, that's easy.
It's like the math part's easy if you remember how to fill out the table. The answer is flip it, -1/12.
Yay, we did it. Oh, yeah.
Yeah. Oh yeah. Now that you talked about it, I remember that now.
Wait, is it still recording?
Yes. Okay, so that's a small sample of test-inspired stuff that you'd see on Wednesday or Thursday.